Hello students, welcome you all to this online session. Myself Prerana Shinde from the Department of Chemistry, S.V.K.T College, Devali Camp, Nasik. So today we are going to see the topic from the FIBSc, that is the thermodynamics. That we are going to see the objective of thermodynamics, limitation of thermodynamics, and the introduction of terms like the system and surrounding, open, closed and isolated system, homogeneous and heterogeneous system, macroscopic system and its property, state of a system and the state variables. Extensive and intensive property, thermodynamic equilibrium, thermodynamic process. In that we are going to again see the laws of thermodynamics, the 0th, 1st, 2nd law of thermodynamics and the problem based on these aspects. So, the student will understand the objective and limitation of thermodynamics. Student will learn the basic terms related to thermodynamics. Student will also learn the 0th, 1st, 2nd and law of thermodynamics. Student will able to apply the thermodynamic principle to the physical and chemical processes. So, what are the objective of thermodynamics? Thermo means heat and dynamics means in a motion or a mechanical work. Hence, thermodynamics is a branch of science that deals with the conversion of heat into mechanical work. Thermo is a heat, so heat related changes, that is thermodynamics. In a wider sense, it is a branch of science that will deal with the quantitative relationship between heat and other form of energy. To predict the feasibility of process from the thermodynamics, we can conclude the feasibility of process. Whether the process will occur under given set of condition can be predicted by applying the principle of the thermodynamics. To estimate the yield of product, in organic chemistry we can see that there are number of chemical reactions we are performed day to day, but how much amount of product in a quantity, that is a 98% yield, 20% yield, that you will come to know with the help of this. Helps to predict the yield of a product in a reaction by knowing up to which extent reaction takes place before containing the equilibrium. The third is to deduce some important relationship, like can deduce the important and useful results such as a Raoult's law of lowering vapor pressure, expression for the depression in freezing point, elevation in boiling point, distribution of law and the phase rule. So, from that we can conclude. Limitation of thermodynamics, the study properties like pressure, volume, temperature on microscopic quantities. Large group of ion molecules are the atoms and not for the microscopic quantities like individual entity, that is atom, ion or molecule. Thermodynamics deals with only the macroscopic property instead of the microscopic quantities. So, it is the first limitation of thermodynamics. It predicts the feasibility of reaction but gives no idea about the time taken or rate at which reaction proceed. Here is another branch which evolved for to take the rate of reaction, that is the chemical kinetics, but the thermodynamics does not predict the time for the reaction. The treatment limited to initial and final state, not about the path by which change brought about, that is does not reveal the mechanism of process. Thermodynamics first and the last limitation of these, that is it always depend upon the initial and final, that is you always take the credential like P1 V1, P2 V2, these are what the initial and the final condition. It does not depend the which kind of path the system has followed. So, this is also the limitation of a thermodynamics. So, introduction to the thermodynamic terms. The first is system. The part of universe considered for the thermodynamics studies is called as a system. Surrounding, the race part of universe excluding the system is what the surrounding. If you take the cup of tea, the tea is a part of that system, or the cup you can conclude it as a surrounding, or other than the tea is what is the surrounding. In that again there are three parts, that is the open system, closed system and the isolated system. Open system, a system which can exchange the both matter and energy with the surrounding is called as an open system. Here you can see the picture of an open system, a cup of tea, which exchanges the matter in the form of vapor and the energy. So, open system, a cup of tea is the example for the open system which exchange the both matter and the energy with the surrounding. Next is what the closed system, a system which can exchange the energy only with the surrounding but not the matter. A closed cup of tea which only exchange the energy As you know, when the tea is inside the cup, a hot tea, the system get hot, so that there is only the energy exchange, not the matter. As it is a closed, no exchange of vapors. Water placed in a closed metallic vessel, that is no exchange of matter, but conducting walls, that is the vessels, exchange the energy. The isolator system, thermos flask is the example for the isolator system, which can exchange neither energy nor the matter, called as a isolated system. Water placed in a vessel which is a closed and having the insulated wall. As a thermos flask is the example for the isolated system. Closed system which only exchange the energy but not the matter is called as a closed system. A closed vessel or a closed cup of tea is the example for the closed system. And the next is the isolator system that exchange neither energy or the nor matter. Here I can take the example of a thermos flask. Next is what the homogeneous system and the heterogeneous system. Homogeneous, homo, that is a uniform. This system which is uniform throughout, or it contains the only one phase, called as a homogeneous system. A mixture of gases, a pure liquid or pure solid is the homogeneous system, which is homogeneously mixed up. Next is what the heterogeneous, which is not uniform, is the term heterogeneous system. This system has two or more phases. Here you can take the system consists of liquid and its vapor, the two or more immiscible liquid, called as a heterogeneous. Here you can take the two immiscible solvent, that is a chloroform water. Here you can take, that is a heterogeneous system, which are not miscible with each other, that forms the two phases, that is what the heterogeneous system. Homogeneous, when a NaCl is dissolved in the water, it forms the homogeneous system. Solid get dissolved in a water, but which is a soluble at a particular temperature pressure is called as a homogeneous system. The macroscopic system and macroscopic properties. So, what are the macroscopic system? As we already said in objective, or we see in objective, that the thermodynamics only applicable for the microscopic system and not for the microscopic system. So, what are the macroscopic system? It is a system consisting of a large number of particles, that is atom, ions and molecule, and the property related to that, that is the pressure, volume, temperature, density, viscosity, surface tension are the macroscopic property. What is the state of a system and the state variable? State of a system is the system means the condition of that system when the various macroscopic properties like pressure, volume, temperature, etc. have been assigned with the definite values. The first and latest state of a system is called as the initial and final step. That you already studied in your 12th, that is the P1, V1, T1, as you applied, that is the initial quantity 1. The second, the suffix denote the second, that is the final step. So, initial and final. So, what is the state? Means the condition of system when the particular macroscopic property like pressure, volume, temperature are applied for that system. And the variables, that is a macroscopic property, are known as the state variables. That most common are the pressure, volume, temperature and composition of the system. That is what the state variables. Thermodynamic equilibrium. A system is to be in a thermodynamic equilibrium if the macroscopic properties of a system in various phases do not show any variation with the time. Pressure, volume, temperature, as we already see, that is the macroscopic property which does not shows the variation. That is what the thermodynamic equilibrium. It implies the following three equilibria: thermal equilibrium, mechanical equilibrium and the chemical equilibrium. In a first we are going to see the thermal equilibrium, that there should be no flow of heat. Thermal related to the heat, related to the temperature, there is a no flow of heat from one portion of a system to the another. The possible when temperature of a system remains constant. If you taken this, here you can take the example, that is a water containing in two beakers. With the same temperature they are, and there is no flow of heat from one portion of system to the another. So, here it is what they are in a thermal equilibrium. Next is what the mechanical equilibrium. It implies that no work is done by one part of a system over the another, or no macroscopic movement of matter should take place within the system with respect to its surrounding, achieved when the pressure of a system remains constant. So, mechanical equilibrium, you can say that the pressure of a system remains constant and no work is done by one system to the another system, called as a mechanical equilibrium. Next is what the chemical equilibrium. This equilibrium implies that no change in composition should occur in any part of a system over the passage of time. As a composition, you can say is the number of moles. There is no change in the number of composition or number of moles, called as a chemical equilibrium. So, these are three types of a equilibrium: thermal equilibrium, mechanical equilibrium and the chemical equilibrium. Next is the extensive and intensive property. The property which depend upon the quantity of matter contained in the system are called as the extensive property. How much quantity of a matter is present in a particular system, from that you can say that is the intensive property or the extensive property. So, extensive, that is depend upon the quantity. Here you can take example of a mass, volume, energy, heat capacity. How much volume, that is how much number of matter is present, from that you can say that is it is an extensive property. Mass, as it is the sum of the atomic number, so how much number of atoms are involved, that depend upon again the matter, therefore mass again the extensive property. The net value of an extensive property is equal to the sum of total number of values for the separate parts into which the system may be divided conveniently. The next is the intensive property. What it is? The property which are depend only upon the nature of a substance and are independent upon the amount of substance present. So, in intensive you can remember it as does not depend upon the how much amount of matter present, instead of that it depend upon the nature of a substance. In an example you can see the temperature, pressure, refractive index, viscosity, density, surface tension and specific nearer is are what the intensive property which depend only upon the nature. Temperature, how much heat is there, pressure, refractive index, these are all what the intensive property. For 1 mole of a particular liquid is the same refractive index as per the 1 liter of liquid. Same for the viscosity, same for the density. 500 ml of bottle contain the same density than the 1000 ml of water at that particular temperature. So, it depends upon the nature of that system and instead of depend upon the how much amount of a matter is present. Interestingly, an extensive property may become the intensive property by specifying unit amount the substance. Thus, mass and volume are extensive, but the density is the intensive property. Heat capacity is an extensive property, but the specific heat is an intensive property. These are two exceptions we can say. Thermodynamic process. In a thermodynamic process, there are different number of processes: isothermal, adiabatic, isochoric, isobaric. So, in an isothermal process, we can conclude if a process is carried out in such a manner that the temperature remains constant throughout the process, called as an isothermal process. In such a process, heat can flow from the system to the surrounding and vice versa in order to keep the temperature of a system constant. So, delta T is equal to 0 or constant, as the derivative of constant is 0. So, you can conclude the isothermal process where the temperature remains constant throughout the process, called as a isothermal process. Adiabatic. If a process is carried out in such a manner that no heat flows from one system to the surrounding or vice versa, the system is completely insulated from the surrounding, that is delta Q is 0. Isochoric process, a process which involves no change in the volume. Choric is related to the volume change. So, isochoric, no change in the volume of the system is called as a isochoric process. Isobaric process, a process which involves no change in the pressure. Baric, barometer, which used for the determination of pressure. From that it concludes that it comes that is a isobaric, where the pressure of that system remains the constant, called as a isobaric process. Next is the reversible process. Process which is carried out infinitely slowly, such that all the changes occurring in a direct process can exactly reverse and system appears to be in a state of equilibrium at that moment. A reversible process is almost impossible as it requires an infinite time for the completion. The process which carried out infinitely slowly, very slowly it carried out, so that the changes may be reversible. So therefore these are what the reversible process. Here you can take in the, if the opposing EMF is exactly equal to the of the cell, then no current flows. In the opposing EMF very slightly less than that of the cell, the very small current is given out by the cell. If the opposing EMF is slightly greater than that of the cell, a very small current flows in the opposite direction. These are 3 examples for the reversible process. A reversible process demonstrated with the following experiment. Take a cylinder having frictionless piston containing a gas at a moderate pressure, due to which the piston will start rising upward. The balancing it by placing a petri dish containing the fine sand over the piston. In the balanced position, the piston will be static. If we add a very small sand grain to the petri dish, the piston will start moving downwards very slowly. On the other hand, if we take out a very small sand grain from the petri dish, the piston will start moving upwards very slowly. In both cases, it demonstrates the reversible process. So here you can see the picture which shows the heap of a sand, which if you add the sand, the pressure goes downwards and the gases get compressed. If we add the gases into or the below the container, then that is a heap of the sand will get increased. So these are what the reversible changes or the reversible processes. Irreversible process. Process which is not carried out infinitely slowly, so that successive steps of a direct process cannot be retraced and any change in external condition disturb the equilibrium. An irreversible process occurs when carried out rapidly. All naturally occurring process like the flow of water down to hill, flow of heat from a hot end to the cold end of our iron bar are the thermodynamically irreversible. As you, there are number of irreversible processes which occur daily on nature. That is the first example is the blooming of flower. These are what the irreversible process. So today we have seen the intensive property, extensive property, different type of thermodynamic property, types of equilibrium. In that we have seen the chemical equilibrium, mechanical equilibrium and thermal equilibrium, different types of process and thermodynamic process. In that we have seen the isobaric, isochoric, isothermal process where the temperature remains constant, isochoric where the volume remains constant, adiabatic where the heat changes are constant. So these are all about the different types of thermodynamic property, types of equilibrium. In intensive property, we have seen the that the property of a system which does not depend upon the amount of matter, but depends upon the properties of that matter. In extensive property, we have seen the that property which depend upon the amount, how much amount of matter is present. That is what the mass volume are the extensive property. In our next lecture, we are going to see the laws of thermodynamics and different types of processes. So this is all about today. Thank you.